Hi, Assalamualaikum. Welcome to ECS 429 Dynamics. Topic 1, Kinematics of Particles. Today we will be doing a tutorial session related to topic rectilinear motion of particles. And for today's topic, we are going to study a tutorial that focuses on an example that is related to free fall motion. So this is the question. But before that, let me explain to you what is free fall motion. So a free fall motion is the motion of an object where gravity is the only force acting upon it. So in case, for example, you drop something down or you throw something out from a building, for an example, it is acted totally on gravity. And this is what you call free fall motion. Now, let's look at the following tutorial question. A ball was thrown up in the air from 1.2 meters above the ground. After 3 seconds, the ball returns back to the ground. Determine the maximum height it reached. Okay, now, like any other moving object, for example, if it considers a free fall motion, we can use the basic kinematic equations. Do you know what is the basic kinematic equations? Now, let's do this together. Okay. Now, this is the basic kinematic equations. Okay. Now, it is really good before we begin this tutorial, we write down what are the important informations that we have to put in and draw in order to solve this problem. Okay, so as you can see, first of all, I have written down the 3 basic kinematic equations. Number 2, I have sketched out you the drawing of the ball. Okay, so first, as you can see, the ball, it is from the question, the ball was thrown at a height of 1.2 meters above the ground. So we can say that this is our initial position, which is 1.2 meters above the ground. Okay, and then it reached a maximum height, and due to gravity it falls back down to the ground after 3 seconds. So after 3 seconds it reached back to the ground. So the question is, what is the maximum height it reached? So it wants to know what is this maximum height it reached. So this is our main focus over the question. We want to find what is the maximum height it reached before it maximum height it reached. Okay, so what other informations do we have to solve this problem? Now, since this is the initial position, S0 is the initial position of the ball, then T1 will equals to 0. But do we know what is the time at the maximum height? No, we do not know. Now, what other information? Do we know what is the maximum velocity at V0? No, we do not know. Okay, but do we know what is the maximum height at velocity, the maximum velocity at V1? Yes, we know, because if an object is projected upwards, when it reaches its peak of trajectory, its peak up there, its velocity is 0 meters per second. Okay? It is very different compared to you dropping a ball at a certain height. So if you drop a ball at a certain height, the velocity at where you drop it is 0. But in this case, you're not dropping it. You are actually throwing it upwards. So when you throw it upwards, you do not know what is the velocity at that certain height when you throw it. So again, you do not know what is the final velocity when you drop down. But now for our main concern for this question, what we want to find is actually the maximum height it reached. Now, how are we going to solve this problem? Now, you have 3 different positions here. Okay, but your main focus is that you want to find what is the maximum height. So obviously, when you look at these 3 basic equations, this first equation here does not have the symbol S, the position. So you cannot use this position, this equation 1, but you can use equation 2 and you can use equation 3 because it both have the symbol S, which is what we want to find. Now, since you have 3 different positions here, and in this equation, each position uses the initial position, where you can see S naught here. So we have this one also we have. Now, for S, would it be S1 or S2? Okay, let's try for S1 first. So this, we have to try for S1. Why? Because we want to find S1. So we will name all the S as S1 and all the V as V1. Okay, now, so do we have S1? No, this is what we want to find. This is our thing that we want to find. Okay, do we have S naught? Yes, we do. We have the initial position. Do we have V naught? No, we do not have. We have to find. Do we have the time? Yes. Do we have the acceleration? Yes, we have the acceleration. What is the acceleration? Okay, because it is falling down in the y direction, the acceleration will be negative 9.81 meters per second squared. Okay, and do we have the t? Yes. So for the next equation, number 3, do we have V1? Okay, do we have V1? Yes, we have V1. Do we have V0? No, we do not have V0. Do we have AC? Yes. Do we have S1? Okay, this is S1 that we want to find. Okay, as you can see, both of these equations has 2 unknowns in it. Okay, for which is the same, which is the unknown is V0. Okay, so basically, how are we going to solve this problem? Because we have 2 unknowns here, so it means we have to find V0 first. And how do we want to find V0? So looking at all the information we have down here, we have the position of S2 here, which is 0. So we have this information here. So basically what it means is we can use the information of S2 here to solve for V0. Okay, so this is S2. Okay, so we have S2, we have S0, we want to find V0, we have AT, AC and T. Okay, so basically it's very simple. Now let's solve this problem. What it means is, in order to find the maximum height, we need to find the initial velocity first, and then once we find the initial velocity, we can put this value into this equation here to solve for S1. Okay, so what is our S2 value? Our S2 is the final position, which is 0, equals to the initial position, 1.2, plus V0 we want to find. This is 3 plus 1 over 2 minus 9.81 times 3 squared. Okay, so what is the final answer for V0? So if you calculate quickly using your calculator, it will be 14.3 meters per second. Now, as I said, once you get V0, you can put back into the equation above there to find your answer for S1. So what is V1 squared? V1 squared is 0. What is V0? Is 14.3. 2 multiply AC is negative 9.81. What is S1? That is what we want to find. And what is S0? Is the initial position of the ball, which is 1.2 meters above the ground. So what is our S1? So our S1 is 11.6 meters. So that is your final answer. So this is correct and this is correct. Okay, so basically that is how you can what you need to do to solve this problem. Okay, I hope you understand. Thank you.